My name is Philip, and I would love to explain how to program called client server using Python. And the client is a program that communicates with the server. And why must the client communicate with the server? I really wanted to write a program that will ask the server to search for a file for it. If the file exists in the server directory, the server should tell the client that the file exists and should also send to the client the URL. That's the path through which the file can be found. So my client is here, my server is here. This is another utility that makes sure that I do the work of searching and downloading of files from the server easily. So let me show you exactly how the concept look like. Now here I have a server here and I have a client system, a server system here. The program is written in such a way that that program is called server actually in the code there. So it has to have some ports are like small windows through which program can communicate and connect remotely, and port are given numbers, specific numbers for each particular port. Each port have a separate number. Now the clients should first know at what ports and what host you need to communicate with. So here the clients will communicate using a particular port number. They must agree on the port number that they want to communicate with. So after the connection is being established, the server will now have a dedicated kind of connection created and a separate port through which the server and the client can begin to communicate bilaterally. So it is something like this one. Before I come to the code again, I will show you exactly what I mean by that through my command environment. Let me first minimize this. Now here I have my files here in this directory. We have what is called the clients and the server here. This is server and this is my client. Two different files, but though they need to run in the same machine just for a simulation sake. So if I need to run my server, but first let me first clear the screen. Now I have to type Python like this, then server.py. So when I do that, now it's telling me that server is listening, or server is currently listening on a desktop, this desktop machine, but at 5643 port. This one is a port number through which the client can connect to. I'll also show you that one too in the next structure to see how it works. Now here too, if I go here too, I'm also here to where I can see my client's file written in Python too actually. So let me clear the screen. I'll not say Python clients, then clients. So when I do that, it should be able to run. When it runs here, you see that the server says new connections accepted from this host and in this particular port. Now this port is at which port that is this designates so that they can communicate continuously until the client is tired or the client stop communicating with the server. But then because the server is a server that needs to be running continuously, even when the client stop this connection, the server should continue listening. Now let me do something like this. So let's say stop. If I say stop, see that the client has closed his own program, but the server is actually listening back in that same port called 564. If I want to connect back again to see or try to run my client back again, if I run, see this time around, it pick a separate port number for that communication, for that dialogue, even though the port number through which it was listening was 5643. Now I want to search for a particular program. Let's say a file. Let us assume that I want to wrap book.pdf. Now, after tapping book for PDF, you see the server search through its directory to see if that book exists. Now, if the book exists, it is sent to the client that will find related books and will give it exact part where the book is. And this is a part of the book. It is found at this desktop name, user HP document, and this one. So actually I have to, for this purpose, I have to create a folder, a kind of a shared folder to simulate a network directory where program can actually connect to. In my document here I have doc. See this doc here, there are other folders. So the server will come down here and search for the file being under searching. It will recursively go through every folder one by one. This is how I achieve that. I need to first and foremost try to share the folder to make it a kind of a remote folder by going through the properties like this properties. Now, if I go to product, I come to sharing. So it is here that share. It's already shared. That's why I have this one. This one is a link or the remote paths through which the server can make it easy to look for the file. If I didn't do that one, the system will, the file will have been searched in my entire system, and that will take a lot of time. So I try to avoid this timing of search just for the simulation purpose. So I dedicated a particular folder for that, and that folder is what is in this one exactly through which it has to search from. Now, if the file is found, then what I'm going to do, I'll just say, okay, now that it has found a file, I can stop the clients from connecting to that one. Then if I stop the client connecting to this server, it says server listening back again to that same port. So I can just, okay, he asked me if I want to save my file. Do you want to retrieve the file? Yes or no? If I say yes, so it means that the file that it has found, and this is a file name here, will be saved. This is a book file name, data type, this is extension, and this is the path through which it has to be saved. So all my source code is like this. Now you see here in the cache files, that is where I save the book. Now let's come to the source code itself. Now here is a server. Here is a server. So here is a server. Now if you look very well at the server, what makes the network easier and more preferable and more easy is the socket library. Is a core library from the Python ecosystem. Now it is important that I need to first create this object called server socket, or socket server rather. Now I use a socket to create a kind of address family inet, that's in the IP version 4, and I have to make use of the TCP transfer control protocol stream to allow for this communication where the session can be created, and then what goes in come in must be well tracked and must be delivered without any error. So you see the port here, I have this port here created, it's called 5643. Alright, and that's the same port that is also created at the client side so that you can communicate other ports. So this particular code here is used to bind the host and the ports to this object. So that means this object is bind to the host, and that's the host name. The host name here will be retrieved exactly from a system. And my system host name, if you look very well here, see that then this is the host name down here. This one is the host name actually. Alright, this is a part of the entire system. So, and the host name still could be a kind of 127.001 to that's a local IP address. So let's come back again to the source code. Now here get me the host name or the local IP address, if that was okay. But after that, I need to also make sure that my server listening to the ports, like what I have here. See, server listening on desktop, this is host name and this is a port. So this server at this point is currently listening on this particular level here. That is where this one comes from. You see, print actually server listening on this particular host and port. So it is important that I listen. If I don't listen, that means my server is not running. So when it is listening, it is running and is awaiting any client to come and connect to it. So when a client connects to it, so a connection will be set up, and that connection will be set up through here when the server accepts the connection. So you accept the connection when the client comes in, and when the client comes in, then a connection anchor and the address of where it is coming from will be actually sent here as a tuple from this place. Now after that, you see I have a print here that new connection accepted from this address. So I created a while loop that will continuously receive and send information to the clients, a kind of a bidirectional communication between the client and server. So I made the while loop true. That means it is a forever loop until a break occur within the loop. So what I did here is very simple. There are two different loops. There's one an outer loop and inner loop. The outer loop will continuously listening if it is in outer. So the inner loop is the one that only handle the sending and receiving part of the program. Now here, after the connection has been established, this particular one connect does receive. It's awaiting. It will be here awaiting a particular connection. Let me show you again how that one works exactly. Now assuming that we have this clients run again back, run like this Python client.py. Now you see that here a new connection has been accepted from this host and they have to communicate on this port here. Now I want to search for a particular, let's say I want to search for something that does not exist. Let me say Mango. I'm not sure Mango is there. Mango.py is not there, rather. Okay, just to see. So when I do that one, it search for it. It didn't see it. Alright, it said it was not found, and it said it has finished searching for it. It didn't see it here. So here that is waiting to receive. See, like it's like a blocking stuff. It's still waiting. It has not ended in the server level. It's still waiting for the client to communicate. That is where this one comes from. That is still waiting. Here at this point is waiting to receive. And receiving the byte of 1024 bytes of information from the server at the time using this particular character encoding. So you have to decode what is coming from that place. So here you start to see if the data that is being received from this client is not a word called stop, exit, end, finish, or close. If any of this one is the data, that means this client want to stop communicating with the server. At that point, it will stop the server to communicate with it at that particular port and at that particular pipe. Now if it is not any of these ones, so you will step in and try to do what? Data received from client. You will print out the data being received from client and you're going to search. You want to search it, but before then we have to send to the client what we are about to do. We are about to search for information. So here we do connection dot send all message encode. This particular information here, message in session, will be sent back to the client to say we are session. So the client will receive that one and print on the console. Now here it has to encode because what goes through the network is a stream, a bit number in byte streams of raw bits, or if you want to call it one and zeros. Okay, it has to be encoded so it can be sent through the wire or through the network. So when that one is done, at the other hand, it has to be decoded back and try to print it out. So after you are sent to this client, you come down here and you call a find file utility that will see to find the file in the directory of the server. And here is a utility file rating, find files. Now the file name of one that is being sent from the client to search, this part is kind of optional. So it means that you might provide to it a particular part you want the server to search the file from. So if file is not null, so you put the file in a raw string so that it can be used probably by the by the os.work. So here we created another function called get extension file, and that's the extension. Get extension is here is to get the extension. This will help us exactly retrieve the extension of the file to make sure that we don't mix up extensions, because most of the time files could have the same name but different extension. We want to get the exact file the user is trying to get, all the clients try to search from. This particular function here determine that we first have to say if the file name is empty, you return. If it's not empty, you create an empty string or extension to an extension. Now for every index starting from the last index number of the length of the file name, that means the last particular value index number minus 1. I mean the file name, that's the length of the file minus 1 will give you the last index number of the element inside the file name. So we take that index number, that's the length of the file minus 1. So you retrieve that particular character there and put in extension, like concatenate extension. So we have -1 step. That means you are decreasing from the large number, decrease until you get to 0. So here we have it here. Okay, we have it here. So when this one goes, if the file name with index 1 or that index is equal to dot, that means we have gotten the index, so we can break it. So when we break it, we now have to reverse it to have it an extension and return the extension back here to us. So here we have the extension to this place. So we have a list of fonts. A list of fonts is like we want to find how many files that is in that search is found in directories. It could be recursively, that could be the similar files in different directories. If they are there, we need to get all of them and put them in the found list. So the found list is created here as empty for. So here we have a kind of OS that recursively search every folder, every directory inside the path, like walk through one by one and return to you the files directly on the root. So we are particularly interested in the files. So from each file, from every file in a particular directory, we search through to find if that particular. We first print the those print you see down here at each print from here. We first print each particular file encountered in the directory in the screen while we are searching, a kind of a verbose information to be displayed in the terminal. So here we get the file name. We get the file name and put it here. But first, you need to make sure that the file that is down here need to be put to get the entire URL. Now, to get entire URL, this entire URL here, this gives us the entire URL. Alright. So the entire URL is now put in the get file name, and that utility down here to retrieve only the file name. Only the file name. So when that one is retrieved, you have the name here. This is a file name. So we have to make sure for the lower, as long as the file name is the same thing as this one. No, this is a file name that is in that search. If the name here that is being retrieved from the part of the file here, the lower character of it is the same thing as this file name that is in that search, then and also we want to be sure that the extension that is you are trying to go for is the file dot end with the extension. Don't forget that the extension is also there to make sure that we get the exact extension that we are looking for. If it's the same thing and the file name the same thing, then we have found the file. We put that one inside the list by appending inside the list. So we append the entire parts of the file that is currently found into the list. If that one is done, we will return it. If not is achieved, we return false. So here the file name is gotten, or the file here. So what we need to do now, we want to make sure we send them to the clients, because file is found. If files and the length of files is greater than 0, that means there's a file, a particular file in the list send. Don't forget there's a list send from the found files. Now here, found related files will be printed actually into the server itself, and also we want to send this information to the clients that okay, we found some found related files, but it has to be encoded here. Why? Because we are sending through the network. Here it was not encoded because we are printing that one directly into the server, just the one you saw running very fast in the console server there. Now for each file into the files list, we send it to the clients. After sending to client, we also print it out to here too. Now if nothing is found, so we send file not found to the clients, and at that point in time, so the clients can decide to search for another file, or the client can say stop to the server. If you say stop to the server, then at that point in time the server will end. But when the end, it fall back to what? It fall back to the outer parameter, because if you send a stop from the client, it's only detected from here. Don't forget that this is a loop, a while loop. For every message and information that comes, if it is from the client here, it's from the client, from the client. If this data sent from the client is stop, exist, and finish, then the loop will stop and it will fall back again to the outer loop. That means continue listening to the coming connection. Like if I come here, for instance, if I come here and I say okay, stop, so that after stopping here, after clicking stop here, my server say connection close with host, connection close with host number this and for this one. So server listen on desktop for the next connection again. So this one actually explain much about the server. Now if you now come down here to the client level, the client here is the one actually that is trying to search for information through the help of the server and the server directories. Now it has to go through similar pattern here. You create a client or you create an object, socket the object, get the host name of the current system. Then also you also have to get the port, similar ports over there with the port of the server listening on. Then you also have to connect. Here we don't bind, we connect. Over there we bind, but here we connect. The client connect to the host and port. After that, this is printed to the console. It's the client now connected. Now we say print the file to search. Here is an input that receive the input from the keyboard entered. So when the message is entered, we try to see if the message that is entered is not stop, exist, end, or close. If it is end of this one, we close. We will not step into the inner loop. This is an outer loop, inner loop. There are also two loops are here. One that continuously send and receive from the clients, from the server rather here, and one that actually here sends to the this one sent to the server. This one here continuously receive information from the server, and here we try to input information by the time we are done receiving from the server. Do not forget that the server will send what is called a finish information. When a finish information is received, there is a break, or when a nothing is received, there's also a break here. You see the nothing and finish information comes on here. Now you see here this one find nothing. When this one is sent to the client will stop, then look for the next file to search for. Or if here is sent to finish or search, finish is searched, this one, if one is sent to the clients, then the client also will actually stop session. That's why we have this one here. Now if nothing is found, you come down here, and also here from the server, this one comes from the server. This data is received from here, from the server. So we'll print it down here to say from the server on the screen, just like we have it here exactly. Let me show you again. Look, we have it here exactly. Okay, now you see here from the server, from the server. So when we have a finish, then that means we stop the inner loop. So we now fall in the outer loop here to search for the next file, or we stop the searching altogether. So here it determines if the finish has been sent from the server. The server will break out of the inner loop or will fall to the outer loop. From the outer loop here, we have enter the file to search again. The input is enter. Then if the input enter is not stop, or is not exit, is not end, is not close, then you send to the client whatever thing you are searching, like a file. Then from there you have this receiving until the finish is sent from the server. Here file not found and data searching and is not finished. That means we want to be sure that we have the file URL actually and sent from the server being saved into a particular variable here. So the data here, don't forget, is from the server. We want to make sure that we get the exact URL. So this one can only be a valid URL if the data is not file not found, session, or finish. So if it is end of this one, then we don't put anything in the file URL. But if the file URL has something, it actually means that there is a file actually found from the server. And then when we are done with this outer loop here, we send a close stop to the server, for the server to stop. Here we close the client. You must close the client. You must close any particular anchor of the network, okay, objects. Otherwise, it's going to consume your resources a lot. So here we created this one here. This one should be actually another particular group of code that should be in a separate function called utility, but we want to put it here for the simplicity's sake. Now here we want to see if the file that is URL is not called an empty string or is greater than, and is also greater than 2. If it's greater than 2, that means something was found. So it asks the question, do you want to retrieve the file? That means do you want to save the file that you just found from the server? If the answer is yes, then we'll not okay. The file URL is like this one. Put the file URL here, then we'll get the file URL, because we are, don't forget that we were trying to actually try to get it right here in the system. It's like be separate if it was in a network, alright, because now we are trying to retrieve a particular file here. Then the file URL, get the file name down here, get the extension. Now look here, this one exactly is the one that actually retrieve the file from the URL. It's a network thing too, and then you put it here exactly in this particular file name. This file name should determine where it has been stored. We maintain the same name, it could be different name, but we maintain the same name. Some could use a kind of a timestamp if they want to, but we want to be stored down here. Don't forget that this one is a should be any network, but because we are using a local machine to simulate both the server client, we put the file down here. You put the file down here. If it's FTP, that means file transfer protocol. If it's HTTPS, then we know that's HTTP. Now here, but we need to actually import those things. We import our utility from get extension, get file name from utilities down here that is being stored, and also imported our URL retrieve from this URL by request. That's an MB from the Python source code. Don't forget that this cache here that is here is actually where we store our information. Our file being retrieved from the server. This is a cache down here. Now I believe that this little source code will always shed light to those who want to understand a little bit about how you can write a network program using Python, kind of a client and server communication. The most important thing here is to have the socket being imported, then create this one exactly. It's important. The two of them share this particular, that you get the socket anchor, you get the host name, you get the port, and the server and client must agree on the port at which they need to communicate, and they need to trade their transactions, if I may call it so. So that also brings us to the point here that now by the time the connection is well connected, so it has this port here, but then the server will create a separate port through which they will have a dedicated channel of communication, so that other clients can also link to it. So it doesn't matter which client and where is it coming from, so far you understand which port to communicate, they can easily get access to the server. But here the work of the server is just meant to search for the file in this server directory, while the clients is just want to tell the server what kind of file to search for. The file to search for is fun. This client is still the one to determine if you need to retrieve that file from the server. All you need is the URL to that particular file, and that is what we try to achieve today. So I believe the code is a little bit clear, and I'm going to send this one to the URL, to the GitHub link, where you can just take time to go through it and understand my step a little bit. Okay, thank you.